Alright, let's draw the orbital diagram for oxygen. So the very first thing we always want to do is we want to count the total number of electrons. So if you look at oxygen, its atomic number is 8. So we have 8 electrons. Alright, so the next thing we want to do is lay out those boxes just like we saw in the PowerPoint, where we've got 1s, then 2s, then 2p. Okay, you can use either lines or boxes, but this is the orbital diagram regardless. Alright, now we just fill in our electrons. So remember, you fill in one direction, then the other, one direction, then the other. Now we have 4 electrons left to fill in, so they fill in all one at a time, and then we add in our next electron. So this is the orbital diagram for oxygen. We have 1s2, so there's 2 electrons in 1s, 2 electrons in 2s, and 4 electrons in 2p. So this is our orbital diagram. Okay. The next thing the handout asks us to do is to write down the electron configuration. So what you do is you count the number of electrons in every single subshell, and write that number of electrons as a superscript. So for instance, in 1s, there are 2 electrons. So 1s gets a 2 as a superscript. 2s then, 2s has 2 electrons, 1, 2, so it gets a 2 up there high, above the s. And then 2p, there are 1, 2, 3, 4 electrons here, so it gets a superscript of a 4, right? And this is called your electron configuration. Alright, so after electron configuration, the next thing it says is to determine the electron configuration shorthand. Alright, before you do that, make sure that you've got all the 1s together, all the 2s together, then all the 3s, then all the 4s. Okay, whenever you're writing the electron configuration, you don't want to just keep it jumbled like the orbital diagram is. You want to make it so it's all numerical order. All the 1s are grouped together, then all the 2s, then all the 3s, then all the 4s, and so on and so forth. Okay, so when we look now at our electron configuration shorthand, what we want to do is we want to look at nitrogen. Alright, so nitrogen, we go from nitrogen and we go back until we find the first noble gas before nitrogen. So we go, okay, nothing over here, helium. So helium is your previous noble gas. So notice nitrogen can be represented by helium. And you always do that for the shorthand. So if you had arsenic, for instance, arsenic would be represented by argon. Tellurium could be represented by krypton. Okay, you always go back to the one that's the last noble gas before you come to it. Okay, so helium, we write that in brackets. Okay. Now helium, if we look at helium, it has 2 electrons. So those 2 electrons mean that helium represents our 1s. So that means we don't have to rewrite the 1s, but we write everything after helium. So that would be helium, 2s, 2, 2p, 4, right? And that would be just how you would write it. So you've got your orbital diagram, your electron configuration, and your shorthand. Okay, and this is what you're going to do for the worksheet. You're going to figure out what noble gas goes in the shorthand, and then write down everything that comes after the noble gas. Alright, so for instance, let's do one more example that isn't on your worksheet. Okay, this is the answer I'm looking for on the worksheet. You have each of these to deal with. Let's say we have something a little bit more complicated. I'm going to assume you guys can all do the orbital configuration, so I'm just going to look at the electron configuration part. So let's do arsenic. AS. It has a total of 33 electrons. Okay, so if we were to write out the electron configuration for it, we have 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6 goes 4s2, then 3d10, and then 4p, and there's only 3 electrons in it. Okay, so that would be our electron configuration for arsenic. Alright, so the big question is, alright, how do we write the electron configuration? And if you note, if you go from arsenic, the last noble gas before arsenic is argon. So we can write argon in parentheses. Okay, and argon has the electron configuration that ends with 3s2, 3p6. So how we would write this one is all we'd have to do is argon is represented by all of this. So we need to include only the stuff that is not represented by argon. So argon is substituted. Instead of writing that whole top part in the shorthand, we can write everything else. But remember, we have to keep it all in numerical order. So your 3 has to come before your 4s in both the electron configuration and your shorthand. So your shorthand should say 3d10, 4s2, 4p3. Okay? And that is electron configurations, shorthands, and orbital configurations in a nutshell.